Hi everyone, welcome back. Stephen Porter again. Today we're going to be talking about electricity. If you had an opportunity to watch the climate science videos that we posted for last month, you'll know that climate change is probably the most pressing problem of the 21st century and one of the most difficult challenges that humans have ever faced. And those changes are the direct result of our carbon dioxide emissions. So for the next part of this lecture series, I want to talk about the single biggest source of emissions to our atmosphere, and that is electricity production. I'm going to introduce you to the concepts that are going to be covered in all of the material in the following videos. I'll introduce you to my collaborator, a real expert in electricity, Dr. Ram Rajagopal from Stanford University, and I'll talk a little bit about the framing idea for the larger lecture series and for the course taught here at Brown called Climate Solutions. So let's dive in. I'm going to start off with a diagram that's quite complicated, but I'm going to walk you through it step by step, and it's really a framing diagram for all of the videos that we're going to be talking about, and a good way to think about where our carbon dioxide and other greenhouse gas emissions are coming from. So I'm going to start with a piece of the diagram. What you see here is 100% of the sources of the greenhouse gas emissions that are warming our planet. In orange and mustard color are the energy-related emissions. So energy production is about 70% of the total emissions that are warming the planet. And of those, the ones in mustard are showing you electricity and heat. The ones in orange are things like buildings and manufacturing, transportation, and the percentages you can see there as well. In the middle of the diagram, you can see some of the end uses in those sectors. So for example, buildings use both electricity for lighting and fossil fuel combustion in furnaces, for example, for heating. And on the far right-hand side of the diagram, you can see the gas that is emitted, whether it's CO2 or CH4, which is methane, or other gases like nitrous oxide, which come largely from agriculture, which you see down here in green. The thing I want you to take away from the diagram for today's conversation is that electricity is the major source of greenhouse gas emissions, electricity production. So if energy production is about 70% of all emissions, electricity production is probably 25, maybe 30, and always growing percentage of total emissions. So why is electricity such a big source of greenhouse gas emissions? It's because electricity is produced globally, mostly by burning coal. So over a third of all electricity production comes from burning coal, which is a fossil fuel. It's actually fossilized plants. Those fossilized plants are made mostly of carbon, and when you burn them, you release CO2. The next biggest producer of electricity, and this number is growing every year, is so-called natural gas. And natural gas is just methane, or mostly just methane. And when that's combusted, it also releases CO2. And also, when that leaks, before it's combusted, it releases methane directly to the atmosphere. And methane is a very strong greenhouse gas. And so gas production, while cleaner at the smokestack, actually also contributes substantially to warming. And then the other sources of electricity are low carbon. And those are things like nuclear power, which has many upsides and downsides, but is a very low carbon fuel. The actual process of nuclear fission does not produce any CO2. Hydropower, so building dams and holding water back and letting that water fall down over a turbine and spin it. And of course, you've almost certainly heard of solar and wind, which are growing very, very rapidly. So we talked a lot in the climate science videos about the need to rapidly reduce emissions in order to stay below 1.5 or even 2 degrees Celsius total warming. And so I want to give you a sense of how much we're going to need to transform our electricity sector in order to reach those climate goals. So in order to stay below 1.5 degrees Celsius, we would need to reduce coal consumption in electricity by 70% in the next 7 years. So it's a really dramatic drop. Now, there is a little bit of uncertainty there, but not a lot. It's going to have to be a very rapid end to coal. And we're going to need to grow renewables like wind and solar that don't emit CO2 when they produce electricity by 5-fold, also by 2030. Now, neither of these are impossible, but there are substantial barriers to doing that, and those barriers are both economic and technological. And we're going to talk about both in the course of these videos. So I want to remind you why it is the case that we will need to reduce these emissions so quickly. And the major point that I want you to take from the previous videos on climate science is that the amount of warming we're going to experience is a direct, almost linear relationship with how much carbon dioxide and other greenhouse gases we have emitted historically. And so I'm just reminding you of this figure from the previous videos that shows in the black line the historical warming trend. So on the x-axis is total emissions of CO2. On the y-axis is how much warmer it's getting, and this is in degrees Celsius. So multiply by 1.8 if you want to know in degrees Fahrenheit. And so it's already warmed up a little over 1 degree Celsius since the turn of the 20th century. And the colored projections out into the future just show you how much carbon we have left. So on the x-axis is total emissions of CO2, how much carbon we have left before we reach 1.5 degrees or 2 degrees warming. And so we really don't have much left in our carbon budget, which is why we need to stop burning coal almost immediately, burning natural gas quickly thereafter, if we want to stay below 1.5 or even 2 degree temperature limit. So I mentioned a minute ago that there are both economic and technological barriers to the transition away from fossil, in particular coal, generated electricity, and to more renewable-based electricity. And this graph here shows you part of that economic problem. So on the x-axis is just years again, time moving forward. On the y-axis is committed emissions, and I'll explain what that means. And the different colors are different sectors. And I just want you to look at the purple sector here. So the purple sector is the emissions that will come from all of the existing electricity power plants in the world if they run their natural life. In other words, when you build a coal-fired power plant, you don't plan to run it for a year and then shut it back down. You build it, it's a huge financial investment, and you plan to recoup your financial expense in the beginning with selling electricity over time. That purple region on this graph shows you if we just run all our existing power plants to the end of their life, how many emissions will come from that. And then the faint purple, sort of on the very right-hand edge of the colored part of the graph, is proposed power plants. So these are proposed electricity generation plants. And if you sum up the purple blob and the light purple blob on the far right, what you see is that there's more emissions that are going to come from power plants as they live out their lives than we can afford if we want to stay below 1.5 degrees Celsius. That's one reason why many people are skeptical that we will be able to achieve that target. That's just from the electricity sector, right? But what I want you to see here is that the transition away from fossil fuels to renewables is both technological, and you'll hear a lot about technological in this side of the in this series of videos, but it's also economic in the sense that there's large sunk costs in existing infrastructure, and staying below 1.5 degrees C will require us to close those power plants down before they have lived out their full life, which is possible, but is going to be difficult in many cases. Electricity also presents a second problem, and I think it's one that's really important for us to consider as we move forward on the transition to renewables. And that is that there is a dire need to increase access to electricity in much of the world. So what you're seeing in this graph is the number of people living without electricity in millions. So that number has been falling since the turn of the century, but there are still almost 800 million people living without access to electricity. And in this definition, electricity just means 4 hours a day and enough to run a light or two and a cell phone charger. If you take a broader sense of electricity and say 24-hour power supply, the number of people without electricity goes well over 1 billion, probably closer to 2. So at the same time as we need to reduce emissions from our electricity sector, we need also to provide for equity, and for equity reasons, we need to allow or provide electricity to a large group of people on Earth who are currently living without it. And that's a key to raising people out of poverty, to increasing educational outcomes, all sorts of other things that are necessary in the 21st century, they need to come from electricity. And so how we both reduce emissions from our electricity grid or our global electricity production and increase the amount of electricity that people have access to is yet another piece of this daunting challenge. And then finally, we need not only to provide electricity that we currently use for the things we currently use it for, like lights and air conditioning and refrigeration, and also provide electricity to the almost billion people who live without access to electricity right now. But we also need to electrify other sectors that are currently running on fossil combustion. So we need to electrify our transportation. And for those of you in the US and Europe, you have seen the rapid rollout of battery electric vehicles, and that's a huge step towards reducing emissions because battery electric vehicles, as you'll see, are much, much, much more efficient than gas-powered vehicles. But that will increase our total electricity demand. We need to switch away from heating houses with oil or gas furnaces and switch to electric-powered heat pumps that are, again, much, much more efficient, but will increase our total electricity demand. So while energy is 70% roughly of our emissions and electricity is a big portion of that, electricity is going to become a bigger and bigger portion. So we now have three challenges to deal with. We need to rapidly transition away from coal and soon after natural gas in our electricity production. We need to increase the amount of electricity that's available to people around the world who don't currently have access to electricity. And we need to replace burning of fossil fuels in other sectors that will increase the total amount of electricity that we need. So this threefold challenge is really at the heart of solving climate change. In fact, zero emissions electricity is the single most important step towards zero emissions. We can't get there without this. Not only can we not get there without this, but this is the biggest step. And it's why we're choosing to focus this first of the solutions part of this video series on electricity production and consumption. So over the course of the next several videos, you're going to learn a little bit about the following topics. The first is, what does the electricity grid look like today? What is the 20th century architecture? And I'll be walking you through the way that electricity is generated and delivered to your home or to your business in the United States specifically, but really the model is the same in any place where there's constant electricity flow, and even really in places where there's only intermittent electricity. Then we'll move into talking about renewable electricity generation, talk a little bit about wind and a little bit about solar photovoltaics. And those are both ways to produce electricity without fossil fuel combustion and therefore without carbon dioxide emissions, at least while the electricity is being generated. It's very exciting that these are becoming the cheapest sources of energy worldwide. But they pose real challenges to the grid that we built in the 20th century to deliver that electricity. And so we'll discuss those challenges in some detail and then move on to some of the solutions to those challenges. Things like storing electricity, flexibilizing demand. Flexibilizing is a tough word, but it's actually not a word. But making demand for electricity more flexible and using technology to do that. And then finally, we'll talk about electric vehicles, which are in the midst of a revolution. Well, I guess solar and wind are also in the midst of a revolution. But in the midst of a really rapid transition from 100 plus years of gas-powered cars to very, very soon the end of gas-powered cars and the transition to fully electric vehicles. In order to do that, the last 4 videos in this series are going to be delivered by one of the world's foremost engineers and thinkers about electricity and electricity production and the grid, Dr. Ram Rajagopal from Stanford University. Dr. Rajagopal is an associate professor of civil and environmental engineering and also runs the Sustainable Systems Lab at Stanford. And he has published a lot of amazing and interesting research on the path to decarbonization of the electricity grid and the challenges. He'll tell you about some interesting experiments that they've done. And so I'll lead in with a discussion of the current electricity grid, and then he'll present in the rest of those videos. So that's it for this intro video. I look forward to talking to you about the 20th century electricity grid. I hope you really enjoy these videos. They'll feel a little bit down in the weeds at times, but just remember, electricity is the biggest source of emissions, single biggest source of emissions to causing climate change, and zero emissions electricity is the only path to a climate solution. And so it's worth sort of fighting through the weeds and keeping that big picture in mind. All right, I look forward to the conversation.